All right, let's dive into something you use literally every second you're online, but probably never even think about: the application layer. It's this invisible yet absolutely essential interface that powers your entire digital life. I mean, have you ever actually stopped to wonder what's going on under the hood when you send a quick message or load up a website? You tap a button on your screen, and almost instantly the digital world just responds. It seriously feels like magic, right? But it's not magic. It's actually a super organized, incredibly fast process. And the secret to how it all works is a system of layers. The one we live in, the one that's closest to us, is right there at the very top, layer 7, the application layer. You can think of it as the front door to the entire internet. It's the only part of this whole complex system that you actually see and interact with directly. So how exactly does this layer act as our window to the web? Well, think of it like a master translator. It's the crucial bridge that takes our simple human ideas, like I want to watch that cat video, and converts them into a language that the massive global network can actually understand and do something with.
You see, every single thing that happens online starts with a person. It starts with you. You decide you want to write an email, search for a recipe, or buy something. It all begins as just a simple thought, an intention in your head.
The second you type that search or you hit that send button, your device's software and hardware spring into action. They take your command and translate it from, human language into pure digital data, the ones and zeros that computers thrive on. And this right here is the critical first step on the network side of things. The application layer is the very first service to grab that digital request you just made. It's kind of like a digital concierge that instantly recognizes what you want to do, say send an email, and knows exactly how to kick off that whole process. So from this point, the application layer packages up your data and sends it on a journey, down through the 6 other layers of the network stack. Each layer does its own specific little job, kind of like addressing a letter, putting it in the right envelope, and adding a stamp, all to get it ready for its trip across the network.
Now, it's important to know that not all applications talk to each other in the same way. Up here at this top layer, all this communication is generally organized into one of 2 main models. You've got the classic client-server model or the more decentralized peer-to-peer approach.
And these 2 models are, fundamentally different. The client-server model, that's like a central library. One giant building holds all the books, and everybody has to go to that one place to get them. Peer-to-peer, on the other hand, is more like a book club, where everyone brings their own books and just shares them directly with each other. No library needed.
So to put it really plainly, in the client/server model, which is what powers most of the web you use every day, your device is a client asking for stuff from a big, powerful central server. But in a peer-to-peer network, every device, or peer, is totally equal. They can both ask for information and provide it, talking directly to each other without any middleman.
Okay, but for any of this to actually work, all these devices need to speak the same language. And that's where protocols come in. You can think of them as the strict rulebooks, the universal languages of the internet, that make sure a request from a laptop in Tokyo can be perfectly understood by a server in Toronto.
A really great way to picture this is to imagine a server farm where every server is a dedicated specialist. So you've got your email specialist over here, a web page specialist over there, a file transfer expert in the corner, and each one is an expert that only understands the very specific protocol for its one job. First up, we have DNS, the domain name system. And this one is, quite simply, the internet's address book. It's that simple. We humans remember friendly names, like Cisco.com. But computers, they need numbers, IP addresses, to find anything. DNS is the protocol that does that quick translation for us behind the scenes. Next on the team is HTTP, the Hypertext Transfer Protocol. So once DNS gives your computer the correct address, HTTP is like the courier that actually goes to that address and fetches the web page for you. It's the absolute workhorse protocol that delivers pretty much all the web content you see. And for email, we've got a little tag team. SMTP, or Simple Mail Transfer Protocol, is like the main postal service that moves letters between different post offices. Its job is to send your email out and forward it across the internet. Then you've got POP, or Post Office Protocol. POP is the local mail carrier who takes that email from the final post office and delivers it right to your actual inbox. Okay, so let's put these protocols into action. Let's follow the step-by-step journey that happens in milliseconds every single time you do something as simple as visiting a website. It's this incredibly fast, 6-step dance. First, you type in a name. Your computer has no idea where that is, so it sends a DNS request out, basically asking, where do I find this? The DNS server, our address book, looks up the name and sends back the correct numeric IP address. Now your computer knows exactly where to go, so it sends an HTTP request, our web courier, directly to that IP address. And finally, the server at that address responds, sending back all the page's code so your browser can put it all together and display it for you. And all of this, it happens in the blink of an eye.
All right, so what about email? It's a really similar process of different protocols all working together, but there are a few different characters involved in the journey of getting your message from your screen all the way to your friend's inbox. So, when you hit send, your email app, which is technically called the Mail User Agent, uses the SMTP protocol to push your message out to your email server. And then, when you check for new mail, your app uses the POP protocol to pull any new messages down from that same server. See? Push and pull. So once your server has your email, its mail transfer agent takes over. Just think of it like a postal sorting facility. It reads the recipient's address and then uses SMTP to forward the email across the internet to their server. Finally, the receiving server's mail delivery agent accepts the message and drops it right into the recipient's inbox, where it waits to be read. So the crucial point to remember here is this. SMTP is the protocol for forwarding mail all across the internet, from one server to the next. And POP is for that very last step, delivering the mail from the final server down to your actual device. It's that simple. One forwards, the other delivers.
You know, when you really zoom out and think about it, this entire digital world we live in, every social media post, every video you stream, every single online message, all of it is made possible by the quiet, tireless work happening at the application layer, powered by its team of specialized protocols. It really is the invisible engine of our connected lives.
So the next time you click on a link or send a message, maybe you'll think about that complex negotiation that's happening behind the scenes. You'll picture that team of digital diplomats, all speaking the precise language of their protocols, all working in perfect sync to bring a piece of the internet from a server somewhere out there in the world directly to you.